right. Could you hit the switch on the actual thing?
Yeah, hit that switch and then plug in the power. But
Yeah.
don't flip here, guys.
Yeah, plug that bottom,
Plug that bottom for me.
the one that's not plugged in. Hello, my name is Ian Sanchez, and I am the leader of Tin Can Robotics. And today we're going to show you the shadowboxing Rock'em Sock'em robots that we made. I was in charge of the documentation, making all of the circuits and schematics, while the rest of my team handled all the other wonderful parts of this project. So I'm going to pass it along to Quentin, and he's going to tell you a bit about the radio.
My name is Quentin Bellamy, and for our project, I worked on some of the radio components of it and the robot assembly. But essentially, just to simplify it, this here radio on both the chess piece and the robot is responsible for sending the user's punches and the user's tilt angle using this here gyroscope. And I'm going to pass it on to Clayton so he can tell you a little bit of the stage assembly.
My name is Clayton Eveland, and I worked on the arena part of the project. Uh, we started off with just a simple design without any of like the ring post or anything like that. There's a flared base to make sure everything in the bottom is encompassed. And then I took some liberty when putting on these stencils to include a little bit of accidentalism, which allows you to purposely use accidents to make it unique. And I also worked on the sewing part of the project. And I'm going to pass it on to Oscar to talk about the LCDs.
I'm Oscar. I worked on helping out with the arena and the LCDs. As you can see right here, I programmed the health bar on them. So, like you'll see that later on, but there's a sensor right here in the chest plate where every time it detects one of these magnets on the arms, it'll it'll take the health bar, like it'll drop the health basically. And that's it.
My name is Nicholas Lewis. I ended up working on the robot design and power supply. Basically, we're using a modified 500-watt computer ATX power supply that we cut the 4-pin and 24 pins up of and have wired the Arduino sensors, servos, solenoids, everything with. I also handled all of the 3D design. So the design on these robots is entirely handmade except for the heads, which were found on printables.com. Which resulted in about 100 hours worth of Fusion 360 work from learning from scratch and really just getting in there and figuring out how to do it. And I'm going to pass it back to Ian so that he can start wrapping us up.
So, like Nick said, everything in here is custom designed. I helped worked on some of the circuitry that went into both the controllers and the robots. So now I'm going to take off the lid for the robot, and we're going to take a look inside just what went into this. You can see we have a relay stack which can help control our punches, as well as all the different cables that we had to kind of finagle in there in order to get all this junk working. So Oscar and Clayton, could you guys start calibrations? That way we could go ahead and show our motion demo. If you look on the controllers, you'll see we have our tilt sensors, all of the other components that Quentin talked about prior. And while these guys are running cal, the robots are ready to go, so let's watch them fight. Well, all right, which one of you came unplugged?
I'm working.
Yeah, yours is working, Clayton ain't. Now, for the sake of brevity, Quentin is going to go and he's going to hold up a magnet to the chest to kind of simulate what would happen if somebody were to win this fight. So if you look at the health bar, do the other one. The other robot. Yeah, do the blue one. Yeah. You'll see that when the magnet is held, the screen says game over, and the head is supposed to pop up, but it seems we're having some issues with our demo today. So I'm going to pass the mic on to Nick, and he's going to tell us what we'd do if we had a little bit more budget for this thing.
So for motion tracking, it takes a lot of design work, and we didn't have a whole lot of budget or time to handle the kind of development that would be needed for something like this. But we hope in the future, if we're allowed to continue on this project and we can get a little bit more funding and have way more time, we can implement full 3D access tracking. Essentially turning this this chest plate into more than just a 2-sensor setup and a full 3 to 4 sensor setup, depending on how we want to handle it. And then robots can be turned into a little bit more than just turning back and forth and punching. They can be turned into something like a full arm or a simulated arm, similar to what a company like Boston Dynamics would have. But we didn't quite have the time for something like that. Just is how it worked out. I'm going to hand it back to Ian.
So with this project, we really want to show off all of the applications of motion-controlled wireless robotics. And while this is a rough draft, like Nick said, this has so many more applications, and we just want to explore it in a fun way that would really be able to show off what this can do for the average person. So on behalf of Tin Can Robotics, I'd like to thank you for checking out our cool robots.